origin of universe. Okay, so in this theory, Hubble was the person who broke ground in 1920 and basically gave rise to the Big Bang hypothesis. Under this hypothesis, he said that the universe is continuously expanding. However, the distance between galaxies, although the distance between galaxies is expanding, the galaxies themselves are not. Okay, so this eventually culminated in the Big Bang theory, and under the Big Bang theory there was a primordial atom which had in almost zero volume. Since volume is zero, density will be almost infinite. Okay, and temperature was also infinite, and this erupted, and this resulted in the formation of the universe. Once this erupted, within fractions of seconds there was rapid expansion. However, later the speed of expansion started slowing down, and the universe started cooling down. Once the universe cooled down, atomic mass began to form. So the first atom that was formed was around 3 minutes after the beginning of the universe, and later, about 3 lakh years later, the temperature of the universe fell down to 4500 Kelvin, which basically gave rise to atomic matter. That was atom, this is atomic matter, and as a consequence universe became transparent. Then next, see, the expansion of universe, this theory was also had a counterpart, and that was known as the steady state theory. The steady state theory basically states that the universe has been the same roughly at any given point in time. However, with greater evidence coming every day, such as cosmic background radiation and James Webb telescope catching an image of the early phases of the universe, we are now more and more sure that the Big Bang theory holds water. Next comes star formation. Okay, so how did they explain star formation? They said that initially the distribution of mass and energy in the universe was uneven. As a result, so there was difference in density, there was difference in gravitational force, and due to this, several different amounts of matter started accumulating together. Okay, and this resulted in the development of galaxies. So these galaxies are spread over large distances inside the universe, which are often light years away, and the diameter of an individual galaxy is around 80,000 to 1,50,000 light years. So 1 light year is the amount of distance traveled by light in a single year. Light travels 3 into 10 to the power 8 meters per second. Now what happened is, when galaxies were formed, inside the galaxies, they were formed by the accumulation of hydrogen gas. Here that we were seeing, when there was density difference and matter was being accumulated, it was mostly hydrogen gas. So this hydrogen gas, when once it accumulated, it resulted in the formation of large clouds of hydrogen. These clouds of hydrogen within the galaxies are called nebula, and this nebula eventually, again there will be density difference, the same thing because of which galaxies were formed. That is the same process inside the random universe. The same process was followed again for formation of, almost the same process was followed for formation of nebula within the galaxy, and within the nebula now again there will be density difference. Okay, because of which there will be localized formation of clumps of gases, and these clumps of gases will eventually compress due to the continued increasing impact of gravity, and finally result in the formation of the core of the star. Once it becomes extremely dense, once the core of the star is formed, fusion begins, and thus source of energy is established. Okay, and the stars are believed to have been formed around 5 to 6 billion years ago. So next comes the formation of planets. Okay, now we know that the stars have been formed within the nebula. Once the star is formed, the gravitational force of this particular star results in the formation of a rotating disk, as we had seen in the revised nebular hypothesis that Otto Schmidt and Carl Weizsäcker had given. Okay, this is a rotating disk of gas and dust which develops around the star. Okay, and once this develops, what happens in the next stage is that this gas basically starts to condense into small round objects. So here inside it becomes small round objects, by the process of cohesion. This is again the same mechanism being just scaled down. We saw that from the universe only. Universe to galaxies through mass and density difference, and gravitational force assisting it. Similarly, within nebula, star, again star, around the star there is this rotating gas and dust disk, and again within the disk through cohesion these planetesimals are being formed. Now these planetesimals will collide with each other, and this will result in the formation of planets around the star. Okay. This process of formation of planets is known as accretion. Now, a few details about the solar system. Solar system was formed about 5.5 to 5.6 billion years ago, and planets were formed around 4.6 billion years ago. And in the solar system there are total 8 planets plus 63 moons. Okay, and the solar system is clearly divided into inner planets, and then there is this asteroid belt, and then there are outer planets. I'll not go into the detail of planet. Anybody can just do the Google search and find out, okay, what are these. So what is the property of these planets? These are terrestrial planets, and they are basically made up of rocks, metals. Another thing that happened with these planets is, due to solar flares, most of their primordial atmosphere has been removed, and these planets are small. Okay, since these planets are small, they do not have the capability to hold their atmosphere down, at least against solar flares. Similarly, these outer planets are basically called Jovian or gas planets. So here what has happened is, these planets are much larger than the terrestrial planets. Okay, they are mostly made up of hydrogen and helium. Okay, and they have retained a lot of their primordial atmosphere, because these are far away and they have the capability or gravity to hold their atmosphere with them. So there arises a question as to why there is a difference between terrestrial planets and Jovian planets. One fundamental reason is the terrestrial planets are closer. So since they are closer, here the temperature is very high, but here the temperature is very low. So here basically only those particles survive in solid state which can sustain high temperatures, and gases basically don't cool down into solids. But here what happens is the gases that form these planets cool down into solids or other types of materials, giving some density to these planets, and as a result they are held together as Jovian planets. However, that is not happening in case of inner planets. Okay, another thing is Pluto was a planet, as we all know. It was then removed as a planet, and another, because it is now considered a dwarf planet. Okay, and another such dwarf planet in the solar system is 2003 UB313. Okay, now comes about the moon. So after we have discussed the origin of the solar system and the planets, we are now discussing the origin of the moon. Initially there was this person called Sir George Darwin. So Sir George Darwin. So Sir George Darwin said in 1838 that basically the Earth and the moon formed a single rapidly rotating body, and the whole thing was dumbbell shaped. Okay, so wait. The whole thing was dumbbell shaped, and it was a rapidly rotating body. Okay, so and eventually this separated into two different bodies, and the part from which it separated the moon separated basically forms the depression where the Pacific Ocean is currently. Okay, this was the standing theory. However, now with a lot of research we know that this is not how the moon was formed. The moon was formed due to a giant impact called the Big Splat. So a body roughly 1 to 4 times the mass of 1 to 3 times pardon my mistake, 1 to 3 times the mass of Mars collided with the Earth, and this resulted in a large part of Earth being blasted into space, and this resulted in the formation of Moon. So Moon was formed around 4.44 billion years ago, around 200 million. Earth was 4.6 and solar system was 5 to 5.6. Okay, now we will deal with the evolution of Earth. So once Earth was formed around 4.6 billion years ago, and then Moon was formed around 4.4 billion years ago. Okay, there were some interesting events which led to the development of two major things. One was the lithosphere, and three major things in fact: lithosphere, then the atmosphere, and as well as the hydrosphere. And once these three were suitably formed for life, these three combined together to form the biosphere. So now we are dealing with the evolution of lithosphere. Okay, so how lithosphere was formed? Initially what happened is the Earth was in a very volatile state, okay, when it was formed, but gradually density and temperature inside the Earth, both of them increased. As a result, since density and temperature, both of them are increasing, especially in case of increasing temperature, these materials began to be separated according to their differential densities. Now density has become a prominent parameter. Density is increasing, but each material will have different densities. Okay. Similarly, temperature is high and Earth is also rotating, as we will see in the future. So differential, due to this, they started being separated into different layers. The heavy metals basically sank. So we can see the core is currently made up of nickel and iron, whereas the light metals came up. As we know, crust is made up of Cl and Cma. Okay, silicon, aluminum and manganese. So after this, what happened is the Earth cooled down further and it became smaller. The outer crust solidified. Okay. And one more thing also I wanted to say, when the moon basically must have struck the Earth, so that also would have contributed. So when this would have happened, that also would have contributed to increase in temperature and changes that would have led to this kind of differentiation within the Earth's lithosphere. Okay, and as we will see in future course, there are various layers within the Earth, such as crust, mantle, outer core, inner core, etc. Okay, and generally the density of material, as we know, increases since heavy metals sank down. Density increases with depth, I mean, because we know that heavy metals sank down. Okay, next comes the evolution of atmosphere. So the evolution of atmosphere, initially what happened is Earth, as we had seen, it was a terrestrial planet, so there was a primordial atmosphere. Okay, and this primordial atmosphere, as we saw, common to most terrestrial planets due to solar flares, was removed. During this period, the differentiation was still ongoing. Earth was newly formed, so Earth's magnetosphere was not very well developed. If you see, magnetosphere was developed around 3.2 billion years ago. So we know, I'm not very sure about this date, I just saw it as a hobby, so you can cross check it for the exact date. But so as a result, what happened, that the hydrogen and helium based atmosphere, primordial atmosphere which was there, this was removed, and now Earth was atmosphereless. So but we know that within the Earth there is a hot interior which is filled with metals and different type of substances. So this hot interior began releasing gases. What kind of gases it started releasing? It started releasing carbon dioxide, methane, then water vapor, then ammonia, and very little oxygen. As yes, nitrogen is important. Okay, and very little oxygen. Okay, so now we see the problem here. Carbon dioxide is more, methane and water vapor is more, but the oxygen is very less, so that cannot sustain life. Then how did life come about? Okay, so this process is called degassing. So next what we are going to see is the evolution of oceans or the hydrosphere. Like, I will put this on hold. This is how the modern atmosphere developed initially. Then there were changes in the atmosphere. We will discuss that after we have discussed hydrosphere. So what happened is, Now water is there in this atmosphere. Okay, water vapor is there. Then this water vapor, as the earth cooled down, this water vapor will condense. Okay, we also know that there is carbon dioxide, okay, which is there in the atmosphere, that will also get dissolved in this newly forming rainwater. We know that carbon dioxide gets dissolved in water, and as a result this rainwater carrying some dissolved carbon dioxide started falling on earth. And once this rainwater started falling, we had the formation of oceans, which led to the creation of hydrosphere. Okay, this process was formed about 4 billion years ago. Okay, around 500 million years after formation of earth. So now what happened is, around inside this, now we know that there is earth, there is say ocean. Okay, there is blue ocean. Now this ocean is basically filled with not only water plus dissolved carbon dioxide from atmosphere, as well as currently dissolving carbon dioxide from the atmosphere, as it happens now also. So this resulted in the process, in the evolution of life. Okay, this dissolved water and carbon dioxide and other biochemical things that were present in the ocean basically led to the evolution of life. Okay, so this happened about 3.8 billion years ago. Life came. 4 billion years ago was ocean, then 3.8 billion years ago life came. And once life came, around 2.5 to 3 billion years ago, there was the beginning of photosynthesis. And this photosynthesis then resulted, as we know, the reaction of photosynthesis is CO2 plus, I'm not balancing it, CO2 plus H2O will give rise to C6H12O6 plus O2. So this oxygen that was created by photosynthesis got dissolved back into the ocean, right? Where carbon dioxide was already there, now oxygen also came. This, once the ocean was saturated due to the, now obviously large number of, this was done mostly by blue green algae. Okay, they were the first form of life, or cyanobacteria. So once a lot of cyanobacteria is there, and a lot of photosynthesis is occurring, eventually ocean will become saturated. Once it becomes saturated, oxygen will be, after that, when new photosynthesis occurs, no more oxygen can be dissolved in the ocean water. As a result, this oxygen will be released into the atmosphere. This process has began about 2 billion years ago, and that led to an atmosphere which has oxygen in it. Okay, now we will talk about the origin of life somewhat more. As we saw that life began in the ocean, then they started doing photosynthesis. We exactly do not know, some we know, but I'm not going into the details. But blue green algae is a very good, cyanobacteria is a very good indicator of life, and we have found cyanobacteria remains in geological formations much older than 3 billion years. So we assume that life originated around 3.8 billion years ago. With this, we have ended the first chapter of 11th class NCERT. Thank you.